Hello, everybody. Welcome to our next series of summer series, next webinar. Today we will focus on footing and anchoring. My name is Alexander Szutkowski. I'm the product engineer at Idea Statica. And for the beginning, you are all muted by default. If you want to have some questions, please put it into the panel next to the on the right side. And after the webinar, we will answer them probably per email. So let's start with the footing and with the information all about Idea Statica, how it handles this thing. First, a little bit about the theoretical background. Idea Statica uses CBFM method. All about the method you can see at on the web page cbfm.com. Eventually, on the web page of Idea Statica, in the section General Theoretical Background. About the footing, there are some things what we have to mention. First, we are using Winkel-Pasternak subsoil model for the compression. For the tension, tensions are carried by the anchors, and the shear force you can select if you want to use anchors, shear locks, or friction between base plate and concrete. All these settings I will show you then later in an example. About national codes, right now we have all checks done for the Eurocode, for the American codes, eventually for the Canadian and Australian codes. The other codes, for example, Chinese, we have only the forces, and the checks has to be done right now somewhere else. About the anchors, I have some small remarks. If you are using mortar between the base plate and the concrete, the mortar has the same grade as concrete, so you cannot make another grade there. It's standard here. And with the washer plates, they are not checked. The diameter of the washer plates are relevant only for the concrete breakout resistance and pull-out checks. So there are small remarks. There are some questions on the help desk. So it's just for the beginning. If you have the anchors, you can choose between the direct or straight anchors or the washer plate anchors. If you are using the washer plates, that means that you are using cast-in anchors. And for these anchors, you can get these checks: steel in tension, steel in shear, then concrete breakout, pull out, concrete buyout in shear, concrete buyout, concrete edge failure. About the concrete splitting, this is partially connected to the manufacturers of the anchors. Because we are using general anchors, this check has to be consulted with the manufacturer. Also, when you have the anchors, the straight anchors, it means the post-installed anchors, bonded or mechanical. Here, about the pull-out, it's again because there are some bonded materials. We do not have information about it, so you have also asked the manufacturer of the anchors and the bonded materials, for example. What you can set up in our software. You can select if you count with cracked or uncracked concrete, and also you can select if you how to compute the concrete breakout resistance. You can use all forces, or you can only select the tension. Then the tension forces will be carried by the anchors, and shears will be carried by the supplementary reinforcement in the concrete block. The same is for the shear, or you can also select none. Then it means then all forces will be carried by the supplementary reinforcement. Again, I will show you then in the example where to find it and where to set it. And I would say let's start with with an easy example. Here we can connect we start idea Statica and click on connection. And here in the first window, you can select which connection you want to create. So let's start with the footing. You can select several types of topology, for example, with the diagonal. We'll start right now with the normal one. And here you can again select what kind of footing you want to use. Here, name, you can write what you want. It's only for your information. And of course, here you can select the steel grade, eventually the grade of the concrete, eventually of the bolts. Let's start with what we have selected and create a project. So we have already prepared connection footing with some loads here set, and let's go to the operation which is connected to the footing. In the foundation block, I will take it from the button. You can select the shear force transfer. So if you want friction, shear lock, or anchors, that you can select. Then the anchor types, straight, washer plate, circular, or rectangular, that's the same. Here is the size then, which is important for the concrete breakout resistance. And what I have already mentioned, to select the type of the concrete breakout, you can find it here in the code setup, and it is the upper part. Here you can see concrete breakout resistance, both tension, shear, or none. And again, here in the concrete block, you can check or uncheck correct concrete. Yeah, so these are the places where you can find it. And for example, if I select the shear lock, you can see here under the base plate, the shear lock was created. And if you do not want the profile we have selected here for the column, it's very easy. You just click on the plus button, and here in the table, we can select a general cross-section, for example. Let's go to tab welded composed, and the last item is general cross-section. So if we want to use, for example, a cross section, we have to put it to connect it from several parts. So the first part will be a plate. We'll leave the thickness 10 millimeters, and the length maybe 100 millimeters. And here is the one part of the shellac. If you want to add another part of the shellac, here you have to select the plus button again. We will use this, the same one, but here we will change it to 100 again. And then it's very important. Right now you have to choose the master component. We will use the number 1. The master point is number 2. And the insertion point will be number 4. And to get the correct position, you have to change the anchor. So we'll get the 90 degrees, and that's okay. Oh, I forgot. It's not. We are not ready yet. I will add another one again. 100. Okay. The master point will be then 8 and 6, and here we will there again 90 degrees. So this will be the general cross section used for the shellac. And if you make the calculation, I suppose everything will be okay. So if you want to know how the results looks like, you can go to anchors, for example, and here again, if you click on the plus button, we have a small feature for you. If you take the right mouse button on this and at this place, you can click on Paint Preview, and all the formulas together with the results, you can check them here in this window. So that was the first example. Let's go to the next one. We will make again a general anchoring, a little bit different. So let's start again with connection. Right now we will choose a general topology and make a click on create a project. First thing, we will add a member, for example, a general tube with diameter 160 millimeters, 140 millimeters, and the T6 millimeters. We will rotate it about 90 degrees and make an offset of 20 millimeters. I will then tell you why. So that was the member. Then we will add a load effects. For example, here normal force minus 6 kilonewton and 1 kilonewton meter for as a moments. And then let's start with the operations. First one, we will make a stiffening plate with the dimensions of 200 times 200 millimeters. And that's it. So, and this will be our base plate for the concrete block. And the next operation will be the concrete block. We will not use our standard operation baseplate, because with the baseplate you have only a vertical possibility to connect the member to the baseplate. We will use the operation board grid or contact. Select, for example, here this board grid, and here you have to change from boards to anchors. So that's all. We can set here rows minus 60, 60, minus 60, 60, and we have to change from plate to, oh no, plate is okay, correct. So that's, you can see right now we have a concrete block under the base plate. Right now what we have to do is to connect the member with our base plate. For it we will use stiffening plate again, and that will be minus 60, 300, 100, 100, and it's minus 200, and again here 90 degrees. So that's the next one. And the next operation, again a stiffening plate. One 140, 100, 100, plate SP2 as a doubler, and we will unselect the welds. It will be done with another operation. So let's make a copy of it, of this plate, and change the location from front to rear. And the next operation will be a cut of the plate. We will cut the plate SP3 with SP1, and the welds will set to 4, and this operation can be copied to SP4, and we change the position of the weld. So you can see everything's okay. So and the next operation will be to put them together, these all 3 plates. So for this operation, we will use again the operation board grid or contacts boards. We will connect 3 items, SP2, SP3, SP2, and SP4. And here minus 50, 50, 100. So, and the last operation will be, yes, and you can see here, this offset, I set it wrong. We have to set them to minus 20. So let's go back to the operations, and the last operation will be cut of a member. We will cut the member 1, cut by a plate SP2 with a surface, and here are the welds. So, and that's all. We can click on calculate and we get the results. Oh, forgot here we have to, in the grid, it would be better probably not to use friction but anchors, and make the calculation again, and we can see everything is okay. And again, if you go to check, you can see, for example, information about the concrete block compression resistance check, for example, here in this case. Maybe some hint for you. I will do a small change in this footing. I will change here the member. I will set it here, the offset to 0 and the anchor to 0. Let's suppose that this is another type of connection and will be a connection only with a 1 bolt. That means only normal forces will be acting on the member. So let's go back to the plate SP2. We will change it a little bit with this editor. We will apply rounding on two edges. Here 3, and we will change to 3 and 4. Okay, let's look what happened. I will click on transparent here, so you can see here the plate was changed to a rounding, and this operation with the grid we will change it, and this will be a 0. So, and now if we are going to calculate, we can see what's going to happen in our results. You can see we get here analysis with in red with 0%. What does it mean? It means that we applied on the member 1 all the forces. It means normal forces, shear forces, and moments. And in this case, we get a mechanism. If you have such results, you have to check this item, model type. And in our case, we have to change it from this one to normal forces and the shear forces. Eventually, in this case, would also help if we will change only to shear forces, normal forces, and the moment vertical to our board. So if we make again the calculation, now you can see everything is okay. So it was the second example. And the next one will be a new feature what we have in the version 20, partial supported baseplate. So let's take the first example, what we already have designed, and we will delete this operation about the footing, and we will add a new member. This member will change the direction, and here we will add some more. Oh, excuse me, this was not correct. So I will add some operation, cut by a member, and 2 column bounding box further, and we will add some offset. Then we will copy it, column 1, offset 0, to the surface, and we will add the welds. So right now we have prepared our footing and how to add the concrete block. So let's go again to the operation grid board grid or contact. Change fasteners to anchors. And we will use the empty bottom flange. Can leave it as it is. Straight orthogonal. Okay, here. Maybe minus 50, 50, 50, 150. And then we have to change in the foundation block firm related to plate of member, member to MT, and the bottom flange. So right now we have a nice concrete block, but it looks a little bit strange. It's too long. Why is it too long? It's the explanation is here. You have to change to the check of stiffness. And here in our stiffness check at the member M2, you have this information. For the stiffness analysis, we suppose that the theoretical length for the moments is 6 meters. It's a default value. You can, for example, in our case, we can say, okay, the theoretical length is 3 meters. Check it and go back to our analysis. And here you can see the concrete block change to 3 meters. So let's go back again to the concrete block. And here are the position offsets. You have the possibility for the base plate, select 4 numbers for the base for the offset. So if I say 200 millimeters, 200 millimeters, 200 millimeters, and 200 millimeters, then the offsets from the base plate is to all of these sides 200 millimeters. But so, and if you want to have a partially supported base plate, you have to change this second position from 200 millimeters to minus 2050. So, and in this case, you will get then the partially supported base plate. So, of course, if you leave the 6,000 millimeters in the stiffness analysis, then you have to say, for example, here 5,500. So that was the third example. And the last one is the continuous base plate. You sometimes need to support several columns in one row. And again, it's also possible in Idea Statica. I have already prepared it for you, at least the columns, and I will show you now how to add it. So first operation will be again the base plate. Here, this one. It will make the base plate for the first column. And all you have to do is to extend these base plates under the next columns. But we will first change from 2 profile symmetrical to rectangle. So you can see it works okay. And here and going length, for example, 500 millimeters, 300, and here 200 and 1500. You can see we have already 2 anchors in the base plate, and I would say that's all, but we do not have these 4 columns connected to the base plate. So for this, we have to add the operation cut, and that means that we have to cut it by the base plate 1, bounding both spiral, and here, not the column, but the member M2, and we can make a copy of it and change it from M2 to M3. Again, copy M4, and again M5, and that's it. And if we make the calculation, everything should be okay. Takes maybe a little bit longer. Well, anyway, this works in this way. So let's go back to the presentation. That was the last. It was the last. Excuse me. It was the last example for today. There are some questions because I'm here alone. I will answer them then per emails. You will get them direct in your Outlook. After the webinar, I would like to, if you can, please finish our short survey. The recording of the webinar will be on our web page, probably tomorrow or Friday. If any one of you doesn't have our Idea Statica software, please go to our web page and download our trial. And if any questions or more, please check our support center where you can find a lot of information, not only about the footing, but also about other things. Our next webinars will be on August the 12th and August the 19th. The first one will be about steel connections, about the connections if you have in your construction joints very near one or two in very close position. And the concrete webinar will be about locally loaded areas in concrete details. If anybody of you needs more practice, I would recommend our Idea Statica campus, where you can where you get support when trying designing joints and more. So that's what's for all today. Thank you for your attention. Goodbye.